All right, welcome back to episode 14, ReRevisited. I am Reed Evans. Twitter is @ReedandEvans, and this episode is brought to you with help from Toastal, who's a buddy of mine and is a hair twin. Really, if you look at our bios on Twitter, you'll see what I'm talking about. So we're going to go back to the same thing that we chatted about yesterday in episode 13, which I'll link to in the notes here. Same kind of thing. We got our connection. We've got our connect, which takes credentials to a future. Execute, which takes a query and a connection to a future. Close, which takes a connection to a future. And what we want to be able to do is to connect, then execute, and then close the connection, but return the result from the middle step here, that execute is the result that we want to return. And so Kyle mentioned, he said, hey, could you not use a compose K in there? And so what compose K does is it collects together a whole bunch of functions that go from an A to an M of a B, which is basically exactly what chain gives us. So it basically just allows you to compose, but rather than composing from an A to a B, you're composing things that go from an A to an M of B. So things that are elevated into some sort of a context. So I said, well, yeah, probably we could, but we'd still have to keep that T concept. So I wanted to see what that would look like. And thanks again to Toastal there for giving me a hint of an episode 14. Keep the recommendations coming here. But so what I did was I created this composed function. This composed function, we're going to query credentials and query, very similar. If we look at our calling code, this is completely unchanged except for changing the name of the function from episode 13. But what it allows us to do is to compose K. So connect takes an A to an M of B, right? Just abstracting this one level up. Rather, it takes a credentials and returns a future of an error or a connection. But if we were to genericize that, which is a word I just created, we're going to, it's essentially from some sort of an A to a context of a B. And so compose K, that's what it takes, is a spread operator of those. So any collection of those. So we're going to connect, and then we're going to call this then do function, which actually I think reads better than T anyway. So I'm really kind of happy with this approach. But with then do, we're going to query. So then do, if we look at my signature here, chain of M. So this is basically saying that whenever we see M, it has to be a type that can be chained. But we're going to take an A from an M to a B. Then we're going to take a function. We're going to accept a function from an A to an M of a B. We're going to accept another function from an A to an M of we don't care. And then we'll receive an A, and we're going to return the MB. So in other words, we're going to do this thing, then we're going to do this thing when we're supplied with an A, and we're going to return the result of the first one. So in code, we're going to do f of x. We're going to apply x to f, so that's our A. We're threading into this function here, so we're going to get an M of B. And because M has to be chainable, then we can say dot chain. We're going to get the result out of the f of the x. So this is the B portion. What we're then able to do is to do g of x, which is basically then taking our second function. We're taking x again, which is our A in this case. We're going to thread that into here. We don't care what this context contains. Because we're already within this chain, and because we're already within this chain now, we can just map over this, because the function that what we would need to do in the body of this is actually just to return this value that we already have. So that's why we can map rather than having to chain again in this case. But basically, we can just return this res argument or variable, whatever you're going to call it. But it basically ends up being the B from our M of B. And so when this all gets bound up, what you'll end up getting returned is an M of B, because all of this is within this chain. So we know when we exit from this chain, we're going to have something back in our context. And because it's chain here, it'll be in the chain context. One thing I will note is that because this g of x that we've got here, because I'm only calling map on that, technically this m could just be a functor. It wouldn't actually have to be a chain because all we're doing is map with it. Just something to note there. And if that doesn't necessarily make sense, then just forget I said it. But the way that ends up composing is it ends up composing together really nicely. So we can say we're going to, our composed, which is a function, it's just composed. We're going to compose k, we're going to take connect, and we're going to take then do, and we're going to pass our execute of a query. So once again, we're passing the first argument in here to execute. Then do is going to receive the result of calling connect with credentials, and then it's going to pass that through. So then we get a connection. So if you're keeping track here, the connection is in fact our A in this case. So the A comes in, and it ends up being X here. Let me just go ahead and change it to A rather than trying to keep all those things in our head. So then we have our A here. And so we're going to call F. So this is our first function. On A, we're going to chain the response. We're going to call G on A, and then we're going to map that and return the result. So then do takes our connection, feeds it into the result of passing one argument to our execute, which is the connection. Close also takes a connection, and so you see this same A gets passed into G of A here. So we still have the A's applied to both functions, and then we're just going to map over because we're already in our context after calling G of A because it returns our context. And so there you have it. Actually, I guess from that standpoint, it is nice if this is a chain rather than a functor, so that we can say that it's still returning the same chain context that we passed in to begin with. Anyway, this does the same thing. I don't know about you. I think this reads a whole lot cleaner. I think then do is probably a better name than T. But anyway, let me know what you think. Thanks. This has been episode 14 already. T ReRevisited. I'm Reed Evans. Thanks.